All right, so we have a question here. It says log a x plus 3 and log a x plus 12 are three consecutive terms of an arithmetic progression. And they want us to find the values of x, right? So an arithmetic progression is like a list of numbers where each number is formed by adding a certain number, which is called the common difference. Okay. So an arithmetic problem. Madam Juliet, kindly mute your mic. Okay. Yes, so an arithmetic progression is a list of numbers where each number is formed by adding the common difference. For example, if you have a list like this, 3, 5, 7, and 9. Okay. So here we have a sequence of numbers. Each number is formed by adding the common difference. What is the common difference in this case? You're going to say 5 minus 3, that is 2. So 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. So it goes on. So here, we're also going to first list these logarithms and put them first in the form of an arithmetic progression. So we have first we've got log a x, log a x plus 3, log a x plus 12. So in this arithmetic progression that I showed you here, right? 5 minus 3 equals 2. 7 minus 9 equals 2. So what we're going to do here is we're going to put these logarithms in the format like we're trying to find the common difference. All right, like we're trying to find the common difference, and that way we're going to be able to get our value of x. So this is what I mean. All right, to get our common difference, you can subtract log a x plus 3 minus log a x, and then you equate it on the right hand side, right? You can also say, if you want to get the common difference, you can say log a x plus 12, this is a 12 here, minus log a x plus 3. So what I've done here, if we can look at this arithmetic progression on top here, you can say 5 minus 3 equals 7 minus 5. We're supposed to get the same common difference. So now once we put the logarithms in this format, we can use the laws of logarithms, the quotient rule. Remember the quotient rule whenever you're subtracting logs? They're going to say, let me write the quotient rule here. Log A m over n equals log A m minus log A n. All right, this is the quotient rule, and this is what we're going to apply on both sides. So here we're going to say log A x plus 3 over x equals log A x plus 12 over x plus 3. Okay, so the next thing that we need to do, since we've got we have a log a here and a log a this side, we can cancel them out so that we remain with x plus 3 over x equals x plus 12 over x plus 3. Equals x plus 12 over x plus 3. So now we can be able to solve for x. So we'll cross multiply first. We're going to say x plus 3 times x plus 3. And then we're going to multiply x multiplied by x plus 12. Okay, so we expand on both sides. So we're going to say x times x, get x squared, x times 3, going to get 3x, right? Then we're going to go and say 3 times x, that is 3x, 3 times 3, that is 9, equals, this other side we expand, you're going to say x times x, x squared, x times 12, that is 12x. So we have to bring all the terms on one side so that we leave a 0. So first, before we take all the terms, first let's simplify the left hand side. So it will be x squared, 3x plus 3x, that is 6x, plus 9 equals x squared plus 12x. So here we move these two terms over to the left hand side. So we're going to have x squared. When this positive x comes, this side becomes negative x squared. So x squared minus x squared plus 6x plus 9. This 12, when it comes over the side, minus 12 equals 0. X squared minus x squared. Yes. Uh-huh. Thank you, sir. Okay, yeah, it was a 12x here. Thank you, thank you, thank you. Yes, 6x. Thank you, sir, for that. Minus 12x plus 9. Yes. All right, so x squared minus x squared, that is 0. 6x minus 12x, that's negative 6x plus 9 equals 0. So we can take this 9 over to the other side. So when it goes the other side, it becomes negative 9 here. So we divide both sides by negative 6. Negative 6 divided by negative 6, they cancel. So x, here we can simplify this. 3 goes into 9 3 times. 3 goes into 2, not into 6 2 times. So you can say x equals 3 over 2. Or if you want to put it as a proper fraction, we say 1.5. So that is our value for x.